So, welcome back to the lecture of software engineering. Yesterday we have covered incremental development model process. Today we are going to discuss about reuse oriented software engineering. So basically, as I have already discussed in the previous lectures, these are the software process models that are much required in order to develop a software in an effective manner. So once the three phases that are more important, that are T, C and S. T stands for time, C stands for cost and S stands for scope. So together with the help of customer as well as the developer, we can have some cost effective solutions for a particular requirements that needs to be catered in a particular timeline. So we have reuse oriented software engineering, where already some of the COTS libraries, that is commercial off the shelf systems, are available, and these libraries are having some of the existing components that are going to help in the new software systems that can be taken as a sub modules, and it can be introduced from the COTS libraries, and we don't have to develop that particular module from the scratch, such as login module, sign up module, these inbox, these kinds of modules are almost having similar or identical features. So we can have the standard templates and we can use these standard existing components from the COTS self systems. The typical stages are the same. First, when we talk about reuse oriented, first we'll go for the component analysis and requirements modification, system design with reuse, and the final is development and integration. So let's talk about all these process stages one by one. In component analysis, we are going to analyze that in order to furnish the set of requirements that were given by the manager, what are the components that are already available in the COTS libraries that can be directly fetched and embedded in the software. So we need to analyze that particular component, that whatever mechanism we are going to use. After that, if let's say one component is going to fulfill my 80% of the requirements, so what needs to be done in the second phase, we can go for some requirements modification. We can have a one-to-one interaction with the customer, that some of the new requirements that we may add in the existing component, that is the internal policy of the community. We'll modify the requirements and then we'll design the system, or we'll go for the system design with the help of reuse principle, right? And final is, once we have done with the system design, we are going to go to the next phase, that is the development or implementation of the project or the product. And finally, once we have done with all the modules, all the components, we are going to integrate all the modules and we'll make the system as a whole. So it is quite a prominent approach, that reuse is the new standard approach for building many types of business systems, as rational unified process is much more concerned and focused on business perspective, right? So this is the typical process that we are going to use in order to develop any software with the help of reuse oriented software engineering. We'll start with the requirement specification. Once we have done with this, we are going to analyze the components that are already available to us. We'll modify the requirements according to the components by looking into the libraries. We'll again go with the system design. We have already explained this with the help of reuse principle. We'll develop the system, integrate, and finally we are going to validate the system from the user's perspective as well as the customer's developer's perspective. So typically these are some software components, web services that are developed according to the service standards and which are available for remote invocation, that is RMI. Many times we are known about these facts. Collections of objects that are developed as a package to be integrated with a component framework such as .NET, J2EE, J2ME, right? We have some standalone software systems, that is the part of COTS, component, commercial off the shelf systems, that are configured for a use in a particular environment, right? So the process activities are like, therefore same process activities that needs to be followed, because my goal is to focus on the development, focus on the design, focus on the testing. We are going to interleave all the sequences of technical, collaborative, managerial activities, not concerned about these things. So the four basic process of activities are the same: specification, development, validation and evaluation. These are organized in a typical fashion by using different development paradigms, right? In waterfall model, these are organized in sequence, whereas when we talk about incremental model, we'll say that leave the specification, leave the design, focus on the development. So depend on the process, we are going to use the systems activities. We have software specification, the process of establishing what services are required and the constraints on the system's operation and development. Requirement engineering process, I have already discussed a lot about this requirements engineering process, that we'll first check whether technically and financially will it be feasible for us to build or to develop that system. So this is the part of feasibility study. Once we have done with this, we are going to focus on requirements elicitation and analysis. That means all the stakeholders that are the part of the system are going to tell us that what requirements that needs to be met from the developer side and what is the expectation from the system, right? Then we have requirement specification. We are going to give a standardized way by which we can define all the requirements in detail. Once we have done with this specification, we are going to validate those requirements. That means we are going to check the validity of the requirements. Is it any requirement that we cannot complete, right? So this is the part of, you can see the requirements engineering process. We'll check the feasibility study, and the best part of this diagram is we have the output. The output of feasibility study is feasibility report. The output of requirements elicitation and analysis is system models, right? Requirement specification, the output will be user and system requirements. And when we talk about the final stage, that is requirements validation, we'll be concerned about the requirements document. And the inputs as well as the output from all these phases are going to accumulate in this last phase, that is requirements validation, which is going to give us the final document, that is SRS, right? This is software design and implementation. Now whatever requirements that we have gathered in the SRS, or I can say the system specification, now it's the time to convert that specification into an executable system, or I can say a prototype, right? You have heard about the software prototypes. We can design a software structure that can give us the realization of the typical specification that we have already used. Implementation will translate this structure into executable program. These all the activities that are the part of design and implementation are closely related, and that may be interleaved, right? As of now, we'll have a general model of the design process. These are the design inputs. You can see I'm highlighting this. These are the design activities and these are the outputs. That means these design activities needs to be given some inputs, that is platform information, requirement specification, data description. When we'll give all the information, all the requirements, all the data descriptors for the design part, that is much required. In the design activities, the architectural design is going to be made, the interface has to be done, the component level design has to be made, the database design has to be done, right? These are all the essential parts that are related to the overall software development, or it is going to help us, right? And the outputs will be, when we talk about architectural design, it is going to map the system architecture. When we talk about database design, it is going to give us the database specification. When we talk about interface design, it is going to give us the interface specification. And we have component design, we have component specification, right? So these are some sort of design process that is very easy. These are activities that already we have discussed: architectural design, interface design, component design, database design, right? Now, software validation. Verification and validation is intended to show that a system conforms to its specification and it is meeting all the requirements of this customer's needs. It involves checking thoroughly whatever the processes we have involved in order to make that software. Will review all the system setups, modules, we can have undergone system testing that involves executing the system with different test cases with different preconditions, post conditions that obviously are derived from the SRS, because we have the real data in that SRS that needs to be processed by the system in order to give the results. And I must say that testing is the most commonly used thing in validation and verification activity. So that's all for today. I hope you have enjoyed the lecture. Thank you very much.